Hi everyone, we're gonna cover today abstract algebra. So you're gonna be learning with me today. What are we gonna do? Let's say we're gonna do say proof 1. So we want to say, so want to prove this. So there's a bunch of questions I've prepared that we're gonna cover, about 45 of them. We're going to prove to try to learn abstract algebra. So we're going to start with 1. Prove that the identity element of a group is unique. So at this point, you know, a group say G has, we can say 4 main properties, right? So if G is let's see, yes, then it is group if all of these holds. We have closure, associativity holds, identity, element, and inverse, right? So among these 4, we are looking at number 3. That's where we have interest, right? So say proof. So proof, say, okay. So look, so we know that by definition, a group has an identity element. But this equation, so that's, we can say existence, right? Existence of E, right? But now this problem is asking us for something else. We can call this one uniqueness, right? So right there in its name. So prove that the identity element of a group is unique. So how do we know whether this element, we know by the definition of the group it exists, right? How do we know that whether it's unique or not, right? This statement, asserts that it's true, that's unique. So let's try to attempt this. So here it says proof is unique, but what if it's not unique? Can we contradict? Can we find a contradiction if we say it is not unique? Let's see what that gives us. So we want to prove a group G has a unique E, right? Identity element. Okay, now suppose E is not unique, right? That is, there exists E and F, right? Such that E and F are both identity elements of G, right? So suppose there is E and there's also F that are both identity elements, right? By definition of an identity element in G, in a group G, right, or an arbitrary element in G, right? A dot, we should use star. A star G gives what am I saying? Sorry about that. A star E gives A, right? By the identity and the definition of the identity element, right? A star E gives A. If you operate any element, so for example, in Z under addition, right? Any element, call it 1, or let's say 4, right? 4 star what? 4 star 1, right? No, what are we doing? 4 plus 0 is equals to what? 4, right? So 0 is an identity element in Z under plus, right? Here we just use star to denote any, where star is a binary operation on the group G, right? Yeah, all right. So that is set. So suppose, right? Suppose. So by definition, we have this. This is what we care about, right? So from there, right, can make all of this like that, right? So by definition, we have this. By definition, so we can see this. So by definition, we have that. So what do we do then, right? So it means so by definition we have this. It means so we can say case one, right? Case one, E is an identity element, right? Identity element. So this is true by definition, right? Definition, that is A, E equals A. Okay. Case 2, F is an identity element. What does this give us? This means what? It should be true. This means it should be true that A star F, right? Treating F as an identity, right? A star F is equals to what? A. If you look at this true, if okay, this is not good. Okay, so let's try to modify this a little bit. So instead of A, right, so let's use here, right? So A is definition, right? It means that what? You can say let A equals to F. Can start from here. Let A equals to F. Let A equals to F. Let F be an element. All right. So what are we doing? Okay. So case one is an element. This will mean that what? This will mean guess what? By definition, E is the identity element here, right? Means when you operate E on anything, it should give that thing, right? You see? Now case 2. You see why I took it a little step back. F is so that it's a little bit clear. Identity element, right? If this is true, that means that we should have what should we have? Now F is the one, E is just an element. You see, remember this, also or this is also true, right? E star A, you can put it down here. E star A, C equals to what? A. You see, it doesn't matter what order you operate that. So here it means if we have E now star F, right? And now this guy is the identity, it means that we should get E, right? So but now pause, which means that you see this left hand side is exactly the same as this one. You see that? It means F must be equals to E. Contradiction. Addition. You see? We say what exists. We can put here there exists what? Distinct E and F, such that E and F are both identity of G. Can put here and E is not equals to F. So contradiction. to the fact, to the statement, we said E is not equals to F, right? Thus the identity element of a group G is unique. There we have it. There is our proof. All right. Thank you.